Okay, let's go ahead and get started. All right, good morning, everyone. So, any quick questions on anything from last time? All right, so let's go ahead and have a couple quick announcements. So, quiz 3, so it's going to cover lessons 7 and 8, and you have basically now until tomorrow at 9 a.m. to complete the quiz. And then exam 1. So that's going to be from this Thursday at 9 a.m. to this Sunday at 9 a.m. So that's basically your entire window for being able to complete exam 1. It'll cover lessons 2 through 10. So basically, today's lesson will be the last lesson on the exam. And we will have an in-class review on Wednesday for those that would like to take advantage of it. We also have extended office hours tonight on Zoom from 6 to 7:30, and on Wednesday from 6 to 8. So plenty of opportunities to ask questions. And the exam will also be 60 minutes on long Kappa as well. So one thing I strongly urge you guys to do is please find a place with stable internet if you can. So just something to help you guys with taking the exam in a smooth manner. So, because I don't want this situation where you guys have the internet crap out on you and like directly in the middle of the exam and like, okay, well I don't know what to do. I'm like, just find a stable place and work from that, I guess. But okay. So any questions on any of that? All right. So as I asked you guys to do at the start of class, let's go ahead and take a look at the warm-up. So the warm-up says we have to differentiate x cubed plus x divided by x by first simplifying y. So for those of you that did the warm-up, what did you guys end up with? Yeah, there's 2x, right? So, as per what the directions say, we have to first simplify y to see how we get that. So, let's go ahead and rewrite y to see why that's the case. So, we have x cubed plus x divided by x, all that divided by x. So, if we were to simplify that as much as possible, what would we get from that? So if we divide x cubed plus x and divide that by x, what does that simplify to? Go ahead.
What is x cubed if we cancel out the x's?
Well, this is the same thing as x cubed divided by x plus x over x, right? Right, because they both have common denominators. So what would that become? Yep, x squared plus 1, right? Because x cubed divided by x, just x squared, and then x over x is 1. So then, y prime then becomes, well, quick application of power rule says that's just 2x. So nothing too crazy with that. So any questions on that? All right. So here's some derivative rules that we need just for today's lecture. You'll likely need more on the homework, but here's the ones we need just for today's lecture. So cosine of x, derivative of that is negative sine of x. Sine of x, derivative of that is cosine of x. And x to the n, derivative of that is just n times x to the n minus 1. That's just power rule. And f of x plus or minus g of x, derivative of that is just, well, f prime of x plus or minus g prime of x. So that's the derivative of a sum slash difference. And the derivative of a product of two functions, well, as we established last Friday, well, that's just product rule, which states that you have f prime of x times g of x plus f of x times g prime of x. So, the good news is that now we know how to differentiate a sum, a difference, and a product of two functions. So, today we're going to go ahead and round off the 4 basic arithmetic operations and find the derivative of a quotient of two functions now. So, to do that, that's where the quotient rule falls into play. So, d over dx of f of x divided by g of x. So, let me zoom in on this a little bit because that's going to be a bit hard to see otherwise. So, that's derivative of f over g, or if you prefer, f of x over g of x prime, if you prefer that. Okay. So it's going to equal this rather, at first, disgusting formula, but once you actually look at it, you're like, okay, that makes a little more sense, or at least it's a bit easier to visualize. So we have g of x times f prime of x minus f of x times g prime of x, all that divided by g of x quantity squared. Now, at first you're thinking, well, that's a lot of things going on here. Like, how am I going to be able to memorize this? Well, there's a few good ways we can do that here. So, in this case, we can say, all right, well, if we let g of x denote the lower function and f of x the higher function, then there's a nice way we can rewrite the quotient rule here. So we have low times derivative of high, so low d high, then minus high d low, so the higher function times derivative of the lower function, so high d low. All that divided by low squared. So, if you want a way to memorize the quotient rule, this is a good way to do it. And alternatively, I'm going to go on a small little tangent here because this might be useful depending on how much you like working with songs here. So, I remember when I was taking calculus for the first time, and when I took calculus, one of the things we had to go to was this thing called Calculus the Musical. Don't ask why it's a thing, it just is. Anyways, so one of the songs that we memorized as a result of that was the quotient rule song, because apparently that exists. Why not? So one of these songs that we had was the quotient rule song to the tune of Frere Jacques, because again, that exists. I don't know why it does, it just does. So it goes low D high, high D low, all over low, all over low, quotient rule. Again, it's really stupid, I know, trust me, I get it, but it helped me I still remember the song to this day. That's a good enough testament to how good the song is to help you memorize the quotient rule. So again, it's really stupid, but if it works, then it works. So if the song is now stuck in your head, what can I say except you're welcome? So that's all I'm going to say on that. But anyways, one nerdy tangent later, let's move on to actually applying this. Alright, so example 1. So part A, we're actually going to find the derivative of the warm-up function, but now we're going to use the quotient rule to see how we can get that. So, the nice thing here is that we have x cubed plus x divided by x. So in this case, the good news is that we can identify f and g pretty quickly with respect to quotient rule notation. So as we had, well, f of x is always the numerator, so x cubed plus x. And g of x, meanwhile, is always the denominator, so in this case, just x. So in this case, well, if we just do a quick application of power rule here, well, we should end up with g prime of x equals 1, nothing too crazy. And then f prime of x, meanwhile, is just, well, 3x squared plus 1. Okay? So that's that part of it. So what I'm going to do is, from this, is I'm going to color code a few things just so you guys can sort of visualize where things are going to end up being placed. So in this case, we have, well, we have low and then d high. So these two functions are going to be multiplied together. Whereas and then high d low, then these two functions are going to be multiplied together. Okay? So we have, well, okay. We have y prime equals, well, low d high, so x times 3x squared plus 1 minus high d low, so x cubed plus x times 1. And then all that divided by low squared, so just x quantity squared. Okay? So that's that part. So from here, what we'll do is now we'll go ahead and distribute as much as we can here. So in this case, we have, all right, well, if we distribute x to both terms here, we have 3x cubed plus x, and then minus, well, this is just, well, x cubed plus x, this part here, so we just subtract that to get x cubed minus x all over x squared. Okay. Okay, so now what we do from this is we say, all right, well, let's go ahead and simplify this to see what we get out of this. So what would the numerator simplify to? What does the numerator simplify to? All right. Yep, just 2x cubed. So x squared. So yeah, so the x's cancel each other out. 3x cubed minus x cubed becomes 2x cubed. And then so a quick little bit of exponential laws later should tell you that this is just becomes 2x, which is exactly what we got in the warm-up. Okay. So any questions on that? All right. So now let's move on to part B. So part B says, okay, now we have something a little bit more complicated. So we have 2x minus a divided by 9x squared plus a squared. Now, in this case, a is a constant. So what happens now is that if we were to let f of x and g of x, again, denote the numerator and denominator respectively, we have, well, 2x minus a, and then 9x squared plus a squared. So what does that tell us about what f prime of x and g prime of x in this case are? So let's start with f prime of x. What is that going to be here? It's 2, right? Because remember, a is a constant. So in that case, all that says is that a quick application of the constant rule just gives you a big fat 0. Even if there's a square here, a is still constant, so you still get 0 out of this. So because of that, that tells you g prime of x is then what? Just 18x. Good. Okay. All right, so now let's go ahead and color code our functions. So we have, these are red, these are green. So now we have, well, y prime is then going to end up being, well, low, 9x squared plus a squared, d high, so 2, minus high d low, so we have 2x minus a times 18x. Oh. Well, okay, so, yeah, and then all over, well, in this case, low squared, so 9x squared plus a squared, quantity squared. Alright? So, in this case, well, we should end up with, well, so the numerator, the denominator, there's not much we can do, so let's just leave that alone. So we have 9x squared plus a squared, quantity squared. So, in that case, let's just focus on the numerator from this. So, what does the numerator simplify to if we distribute as much as we can? So what do we get as a simplified numerator from this? So if we distribute the 2, then we end up with, well, 18x squared plus 2a squared. Okay. So that's the first part of it. Then what about the second part? So we have distribute 18x to both 2x and a. Well, that'll give us 16x squared and then negative 18 at ax. But because of this negative, that means we have to swap the signs of those. So we have 36x squared plus 18 times ax. So that'll be the second part of it. So then, as a result, what does the numerator simplify to if we add as many common terms as we can? Yep. 2a squared minus 18x squared plus 18ax. Okay? And at this point, that's about as much as we can do, so let's just leave that as is. So in this case, this would be your final answer. Yep?
So we don't need to simplify after the denominator?
Yes, because in this case, in this particular case, there's not really much we can do with the numerator. So in this case, I mean, you could expand out the numerator or the denominator, but there's not really much you're going to get out of that, so yeah. Okay, any other questions on that? Okay. So now let's move on to example 2 from this. So now we have to differentiate the following using the quotient rule. So this is where sort of our second part of our lesson comes in. So here in example 1, we just had to apply the quotient rule. So now we're going to apply the quotient rule to get the remaining trig functions from this. So before we start, does anyone still need example 1 content? Okay, so let's get that out of here. Alright, so example 1, or example 2, we have to differentiate tangent and secant using the quotient rule. Now, if you just look at these by themselves, you might think, well, it doesn't really seem like we can just use quotient rule here. But it turns out we can if we rewrite these two trigonometric functions as what? So starting with tangent of x, we can write this as what? Sine over cosine, good. Over cosine of x. And then similarly, secant is what?
Secant?
Yeah.
It's 1 over cosine.
Yeah, right. 1 over cosine. Okay. All right. So from this, if we were to, use the quotient rule, so we have, let's start with part A first. So part A, so if f of x equals the sine of x, and g of x equals cosine of x, just letting f be the numerator, g be the denominator. So as we established at the start of class, well, f prime of x is just, well, cosine of x. And then g prime of x, meanwhile, is just, well, negative sine of x. So, if we were to apply a quotient rule from these formulas here, or from these equalities here, what do we get out of this? So for those that found the derivative, what did you end up with?
I got sine squared x over cosine.
Sine squared. So what was it?
Sine squared x over cosine squared.
Not quite. So let's take a look at that. So we have y prime equals, so low d high. So in this case, you should end up with cosine of x times cosine of x. Then minus high d low, so sine of x, negative sine of x, all that over, in this case, low squared, so cosine squared. So if you simplify all that, you should end up with, well, cosine squared of x plus, because of the negative, the two negatives cancel each other out, and plus sine squared of x, right? But then, what do you notice from this? We have cosine plus sine squared on top, but that simplifies pretty nicely to what?
1 plus tan squared.
Not quite. So cosine squared plus sine squared is just 1, right? So just focusing on this part here. So in this case, this is just 1 over cosine squared of x. And then taking advantage of the fact that 1 over cosine is secant, as we just established, this becomes secant squared of x. Okay? Which is exactly consistent with what we established back in lesson 6. Okay? Okay? So that's part A. So why don't you guys take a second to do the same thing with part B. So, what did you guys end up with as your derivative? Give you guys 2 more seconds then.
Like the end derivative,
Yeah.
should be like tangent secant,
Okay.
or sine over 2 cosine squared.
Okay, how did you get that?
So you have to multiply like with quotient rule. So you got like low d high minus high d low or low low. And then after you simplify that, it just, you separate it out afterwards because sine over cosine turns into tangent, and then you have a 1 over cosine, so it's tangent multiplied by secant.
Okay. Yeah, so basically, yeah, so f of x equals 1, g of x equals cosine. So in this case, f prime of x becomes 0 because it's a constant. G prime of x becomes negative sine. So in this case, we should end up with, well, y prime is equal to g times f prime, so cosine of x times 0 minus high d low, so 1 times negative sine of x. Okay? And all over cosine squared. Okay? So as you said, this just becomes sine of x over cosine squared. So then if you break it up as sine of x over cosine of x times 1 over cosine of x, break it up as this, then yeah, you should end up precisely with tangent of x times secant of x. which is going to be precisely what you might have seen in the second quiz, if you recall from that. Okay. So, any questions on that? Okay. So, what we're going to do from this is say, all right, now that we have the derivatives of tangent and secant, what I'm just going to say from this is, okay, you can use similar computations to get the derivatives of cotangent and cosecant. So, all I'm going to say from this is recall. So, cotangent of x is 1 over tangent of x, or if you prefer to use cosine and sine, we can use cosine of x over sine of x. And cosecant of x is simply just 1 over sine of x. Okay? So, if that's the case, then you can use similar computations as above to get that, well, cotangent of x, the derivative of that is just, well, negative cosecant squared of x, and negative cosecant, oh, sorry. So, and then cosecant of x is then, well, negative okay. Negative cosecant of x times cotangent of x. Okay? And then I'll say, okay, well, like I said, these are similar computations as in example 2. So I'll just say check on your own. So that's all I'm going to say on that. So from this, if we then put everything together, then let's go ahead and create this little table that gives us the derivatives of all 6 trig functions. So I'm going to zoom in a bit on this just so that way you can see a bit more clearly. So we have sine of x, derivative of that is cosine. Derivative of tangent is secant squared. And then, let's see, secant of x is just secant of x times tangent of x. Right? And then cosine of x, derivative of that is negative sine. And then cotangent of x is equal to negative cosecant squared. And then cosecant of x is negative cosecant of x times cotangent of x. Okay? So there's your table with all the derivatives of all 6 trig functions. So it's nice one. It's one nice little table. So in this case, you might think, all right, well, it's good to know this, but I noticed some of these derivatives have a negative sign on them. So how can I remember which ones spit out a negative sign and which ones don't? Well, let's take a look at some patterns here. So if we take a look at the ones that have a negative sign tagged onto them, what we notice is that the derivatives of them are cosine, cotangent, and cosecant. So what you'll notice is that the trigonometric functions with a co-prefix on them spit out the negative. So if you want a more informal way of establishing this, you can just say the co-prefixes are jerks, and derivative changes sign. Okay? So if you want a way to memorize the which one spit out a negative, then there you go. That's one way to do it. All right. So any questions on that? Okay. So I'll give you guys a second to write that down, and then I'll sort of let you guys take a peek at example 3. So, okay. So, does anyone still need page 3 stuff? Raise your hand if you still need page 3 stuff. Alright, so example 3, now we have to find the equation of the tangent line. So, in this case, we have to find the equation line to the graph of x squared times secant of x at pi over 3. So, as usual, we have to break this up into our usual 3 steps. So, in this case, what is the first step going to be in this case? Does anyone remember?
Finding the derivative.
And then,
Plugging x.
yeah, so then let x equal pi over 3, right? So in this case, find y prime at pi over 3, since that'll give us the desired slope of the tangent line. So here's what we're going to say on this. So in this case, one thing you'll notice here is that what we could do, technically speaking, is rewrite this as x squared over cosine, and that is still completely viable. But for now, let's just go ahead and leave this as is, just so that way we not only have a bit of practice with product rule as well, because we've got enough quotient rule on today's lesson, but we can also have some practice on using the derivatives of the 4 trig functions we have not really used as of yet, or have been exposed to until just now. So I'll say can write y as y equals x squared over cosine of x, and use quotient rule. We'll just use product rule here, and leave quotient rule as an exercise. Okay. Okay, so in this case, if we were to use product rule on this, we could say, all right, well, product rule. So in this case, we need to identify the correct f and g in the context of power rule. So if we were to do that, what would our f and g equal in this case?
Alpha x would be x squared and
Yep. Okay, so f is x squared and g is secant. Okay, good. So in this case, we say, all right, well, f prime of x, well, that's just a quick application of power rule. While g prime of x, well, as we just established, well, that's the derivative of that is secant of x times tangent of x. Okay. So then, if that's the case, we say, all right, well, applying product rule gives us that the derivative itself is equal to what? Go ahead.
2x secant x plus secant tan x squared.
Yep, so 2x times secant of x plus x squared times secant of x times tangent of x. Okay, so that's our derivative, just applying the product rule. So all we have to do now is just, well, figure out our slope, just let x equal pi over 3. So in this case, we have, well, 2 times pi over 3 times secant of pi over 3 plus, well, pi over 3 quantity squared times secant of pi over 3 times tangent of pi over 3. Okay, so in this case, if we take a look at what we have here, you'll notice that we have to put up with secant and tangent of pi over 3. So if that's the case, we're going to need to harken back to our unit circle here. So unit circle. So if we do that, well, let's take a look at what we have. So we have, well, 2 pi over 3, just from this, times secant of pi over 3, which equals what? Anyone know what that is? Yeah, just 2, right? Because if you take a step back, you say, all right, well, let's first figure out what cosine of pi over 3 is. Well, if you look back at the unit circle, that's, well, 1/2. So in this case, you should end up with 2 here, secant of pi over 3. And then plus pi over 3 quantity squared, and then times secant, which is established as 2, times tangent of pi over 3, which is what? Root 3. So in this case, condensing everything down will give us 4 pi over 3 plus 2 times the square root of 3 times pi squared over 9. So this beautiful expression, that's going to be your slope. So that's step 1. Now let's take a look at step 2. So now that we have the slope, what would step 2 be? Does anyone remember what step 2 is going to be?
Again, pi over 3 in the original equation.
Yep, because that'll give us the point on the tangent line. So find point on tangent line. So x colon y. So in this case, if we let x equal pi over 3, then we should end up with, well, y equals pi over 3 quantity squared times secant of pi over 3. So the thing is, we just established that secant of pi over 3 is just 2. So that means that we should end up with 2 pi squared over 9 as our y-coordinate. So that means our point on the line is, well, pi over 3, comma 2 pi squared over 9. Okay. So that's step 2, which thankfully is much nicer than step 1. But step 3, okay. Step 3, now that we have the point on the tangent line and the slope of said line, what do we need to do now? Let's just give someone else a chance to step. So what's step 3? We have the slope and a point, so go ahead.
Is it find the formula using like, I forget what form it's called, but it's like y minus y.
Yeah. Point slope.
Yeah.
Yeah. Okay. So yeah. So now that we have the slope and the points, now we just have to find the equation of tangent line via point slope. Okay. So in this case, we have, well, we got the slope and we got the points. So all you have to do is just say y minus the y-coordinate. So we have 2 pi squared over 9 equals the slope, which is this beautiful expression, 4 pi over 3 plus 2 root 3 pi squared over 9 times x minus the x-coordinate, so pi over 3. Alright? So here's what we're going to do with this. Here's what we're going to do, because this is going to be a heck of a thing to break this up. So what we're going to do is, if we just focus on this expression here, just as a slope by itself, what we're going to do in this case is we're not going to FOIL this whole thing out, but we're instead going to do, we're sort of going to do something slightly different. So if we just treat this as this whole thing here as one expression for now, what we're going to do is we're going to distribute into x and then negative pi over 3 here. And the reason we're doing that is because then we can say, all right, well, that's the same thing as saying 4 pi over 3 plus 2 root 3 pi squared over 9 times x minus 4 pi over 3 plus 2 root 3 pi squared over 9 times pi over 3. Okay? Okay. So the reason I do this is because then we can say, all right, well, we can treat this expression by itself, just multiply by x here, so that way we can just leave this whole term alone. But then what we can do is say, all right, now that we can leave this alone, let's go ahead and work with the rest of the expression to see what our constant term is going to be for this. So if we distribute the pi over 3 into both terms, then we should end up with, well, if distribute pi over 3 and as well as a negative here, we should end up with 4 pi over 3 plus 2 times the square root of 3 pi squared over 9 x, and then, well, we should end up with what? So if we essentially distribute negative pi over 3 into this expression here, then what do we get as our exact value of this expression? So we distribute, so essentially we're distributing negative pi over 3 into here. So what do we get? So this first term here becomes what?
1 pi squared over 9.
Yeah, so it'll be minus 4 pi squared over 9, then minus the second term, which will be
2 root 3 pi cubed over 27.
yep, 2 root 3 pi cubed over 27. All right. So now all we have to do is just add our 2 pi squared over 9 into our expression, and then we'll be done. So we have y is then equal to 4 pi over 3 plus 2 times square root of 3 pi squared over 9 times x. And then once we add over 2 pi squared over 9 over to the other side, then this term will become what?
2 pi squared over 9.
Yep, 2 pi squared over 9. And then this term has a pi cubed, so that'll basically be unaffected. So we have 2 root 3 times pi cubed over 27. This beautiful thing is going to be your desired equation.